So in activity 4.9, we're given a velocity function, square root of 4 minus the quantity t minus 2 squared, which is going to be a half a circle with a radius of 2 that's centered at the point 2, 0. So here's our graph, and we can use this to help us calculate the integral from 0 to 4 of v of t dt. Because what we're looking at is a circle, again, with radius 2 and just its top half. So half of a circle of radius 2, so pi times 2 squared equals 1/2 times 4 pi equals 2 pi. Now let's think about what this means in the context of the problem. Now, because our velocity function is always positive, this gives us both the distance traveled and the change in position. And the units on this 2 pi is in meters. So this object traveled 2 pi meters between 0 and 4 minutes. Now, what about getting the exact average value of the function? Well, that's going to be the integral from 0 to 4 of v of t dt, and we're going to take 1/4 of that. 4 minus 0 is where this 4 is coming from right here. So it's basically 1/4 of our 2 pi, which gives us pi over 2. Now, thinking about what we just did, we multiplied something that was in meters times by 1/4, or divided it by 4 seconds. So this is meters per second. What that is that's the average value that this object is traveling between 0 and 4 seconds. Now, it's not always going pi over 2, but as we can see, but on average, if it were to make the same trip, it would be going pi over 2. In fact, what we're going to do is we're going to sketch a rectangle that has the same area. Well, what we're going to do is right roughly about here is where the height of the rectangle is going to be. Now this is at pi over 2. Because what we're going to do is say, okay, well, if we were going a constant velocity of pi over 2 for 4 seconds, the area of this purple rectangle is going to be the same area as what's under the curve. And if we look, the area is going to be the height, pi over 2, times the base, which is 4, or 2 pi. So we're looking at the same thing in two different ways. First off, we're saying that if we know the distance traveled, 2 meters, we can find the average velocity by dividing by the number of seconds. Secondly, we're saying if we know the average velocity, we can find the distance traveled by multiplying it by the total time.